Hi, I'm Darin from Imply, and I'm here to talk to you about stream analytics. What is and isn't stream analytics? So this all starts, of course, with events, right? So we're generating all sorts of events in today's world. This could be web traffic, this could be information coming off of sensors, this could be, well, all sorts of things. And, when we first started doing events, they weren't that common. But in today's world, with things that are generated by IoT or internet, I can be doing millions or billions of events. Lots of things I need to keep track of and use. So in the old days, we would use messaging systems to move them around, and that's now evolved into the world of streams. So I'm going to have streams, and I'm going to put them into some sort of stream management system like Apache Kafka or Amazon Kinesis, or one of many other options that are out there that use the Kafka APIs. So that's going to give me a reliable way to move that event data into various transaction systems, which is great. But then I need to analyze it. What's going on? What's happening in those streams that I want to take some work on? Now, analytics historically has been all around data lakes, data warehouses, and variants of that, where I'm going to have some sort of data source. I'm going to have original sources that are going to go through some sort of data integration process, ELT, TL, whatever. We'll do ELT and then load in there. Now, that's great for reporting, right? For the world where you're generating a report once an hour, once a month, once a year, some combination. And then that report, usually gets handed off to some compliance, or maybe some vice president might read it and, throw it away, whatever. And that's still an important part of the environment. So this is the world of data warehouses and data lakes. But it's not really designed for streams. You can get streams in there, but what usually happens is the streams have to land in some sort of file and then go through those same ELT processes to get into the database. Well, there's a couple of problems with that. One is there's some latency there. So I'm not getting the real-time information. It's getting delayed. But the bigger problem is, since this isn't really designed for a stream, I might miss data from some streams, or I might double count data from some streams. And if the information here is inaccurate, you can't trust your results. Okay, no problem. So we've seen a world come up of a bunch of stream processors. Now, some people confuse stream processing with stream analytics. Not quite the same thing. So I've got processors out there like KSQLDB, from Confluent. I've got things like Kinesis, so Amazon Kinesis and Analytics. And I've got things like Apache Spark and various Spark vendors like Databricks. Okay, those are all great. And these can do something really useful, because what these can do is go analyze a stream as if it were a table. So I can take one of these tools and grab a piece of the table and say from 30 minutes after the hour to 32 minutes after the hour, pretend that's a table. And then I can write a SQL statement against it and do some selects and understand what's there. Now, that's a type of analytics, but it's not real stream analytics, because there's two key things that are missing. One thing that's missing is the ability to do lots of streams. I can do joins and some other things there. This is great if I want to understand what's happening in one stream, and maybe even two or three. But when I'm dealing with hundreds or thousands of topics and streams coming in, this model kind of breaks down. The more important thing that's missing, though, is this only tells me what's happening in the stream. And in real life, I want to know what's happening now, but I need to compare it to what happened a second ago, a minute ago, an hour ago, last year, the last time we ran this marketing event, the last time a hurricane hit this area, so that I can actually be doing useful comparisons, because data out of context isn't very useful. So how do I combine those things together? Well, first, I still want to use these stream processors partly as analytics tools for quick checking, but mostly to be able to do enhancement and enrichment. So what does that mean? That means I'm going to use one of these tools, I'm going to do the SQL statement there, and generate an enhanced or enriched stream. So what do I mean by that? Well, a common enhancement is this stream, the data coming in doesn't identify the source. Okay, I want the stream to explicitly say this data is coming from source 2. So I can do an enhancement that adds into the data in the stream that it's from source 2, which is not important if it's just one stream, but when I'm combining these streams together, I need to know. Another common enrichment is time alignment. So this stream here might have timestamps in it that are marked in, say, US Central Time, and this stream here might have timestamps in it that are marked in Universal Time. Well, that's going to get me some really weird results if I just blend them together without aligning those timestamps. So I might use one of these tools to query this stream, do a simple conversion to universal time for all of the streams, and then have everything make sure it's universal time and aligned. So that kind of enhancement and enrichment is really useful. And it can get a lot more complicated than that. Spark, for example, can put a machine learning pipeline and actually do things like use a machine learning algorithm to fill in missing values so that I have a good range in case things are missing from the original data. All useful stuff. But then I want to actually get it into a real-time database. And that's a key difference. I'm not talking about a data warehouse. I'm talking about a real-time database. Something that is designed to actually combine historical data and stream data. So of course, the one that I'm going to be talking about here is Apache Druid. And Imply was founded by the people who originally created Apache Druid, which was designed for exactly this. In 2011, when Apache Druid was first made, one of the goals was to be able to ingest 1 billion events in less than a minute and query 1 billion events in less than a second. And they were successful. So of course, today we're able to do much higher numbers as the software has become a lot more advanced and mature. So how does this work with Apache Druid? Well, here I'm going to be doing what we call stream ingestion. So stream ingestion is something built into Druid, and it means that every event as it arrives is immediately queryable. That event goes into a cache, which means when I run a query, I'm able to see every event up to within a couple of milliseconds of them coming in. This is really useful because it means I'm not looking at real time that was 5 minutes ago or even 5 seconds ago. It's now. So if I really want to understand behavior, I want to know what's happening now. This is built in. Anything Kafka or Kinesis is inherently connecting into the Apache Druid environment. So I don't have to set up and manage any connectors. It's just there. That is a really useful piece, but I still need the historical data. So this, in the Druid world, is called batch ingestion. And batch ingestion is getting data in from files or databases. So that's my historical data. That's what happened before. And sometimes that's data that I can't get in a stream, but I still want to include in my analysis. Maybe it's census data. Maybe it's weather data. Maybe it's data coming out of historic systems that don't express streams very well, like, say, SAP, or can't express everything in a stream. So I combine these together so that I have the batch and the stream in one real-time database so that I can do the analytics of real-time things. And I can see what's happening now and compare it to what happened in the past. So I have data in context. And because the stream ingestion is designed for streams, it's what's called exactly once semantics, so that each event will be loaded in once and only once in a way that I can guarantee that integrity. Now, this might be a little different than what you're used to if you've either only been using stream processors or only been using data warehouses. So how do you figure out how to use this stuff? It's not that hard. I'm still using SQL and standard tools from data warehousing and from stream analytics. So the easiest way to do this is go to imply.io and take a look at Imply Polaris. Imply Polaris is Druid as a service, so you don't have to worry about the setup or anything. And we'll give you a free trial. Don't even need a credit card. Just put in your email and have fun. So I hope you have a good time using these things and learning about how to go beyond stream processing and beyond data warehousing to real stream analytics using real-time databases. Bye-bye.